I will solve the first problem that is in the book, page 700. It's a triangular prism that we have to find the surface area using the net method, but first I want to explain it in this way. Now, the figure is something like this. This dashed line is with point represent that is in the back of the figure. Also, this has to be in points. Now, if we make the net, will look something like this: a triangle, rectangle here, triangles, rectangles, rectangle here. Now we have to find, definitely we have to find the area of these triangles that are the same, and we have to find the area of each rectangle then added, or find all this area, but we have to find the area of the triangles at the beginning. Now the triangles has this, we have this information: 5 centimeter, 5 centimeter, 6 centimeter. It's not it's isosceles triangle, it's not equilateral. Then we have to find the altitude here, this height. Now to find this height, I will divide this triangle. We have the information, this is the height. If I know this is the half, will be 3 in this part. Now this is because all the height, all the triangle has to be perpendicular to the base. This is a right triangle. Now we have a right triangle here. And then will be 5 to the second power is equal to 3 to the second power plus h to the second power. This is a formula, it's a theorem that in this case, when Sofia Rivera will tell us in the comment on YouTube what is the theorem that I use in this step. Now, 5 to the second power minus 3 to the second power is h to the second power. H is the square root of 25 minus 9. H is equal to the square root of 16, that is 4. Now this is 4. Now we know already that the height of this triangle is 4. Then the area of this triangle is base times height divided by 2. Will be base is 6 times the height, that is 4, divided by 2. The area of this triangle will be, you may multiply 6 times 4 divided by 2 will be 12 centimeters square. Now this is the area of the triangle. Now, how we find this distance that is here? We have to see the figure again. If we see it, if we add 6, 5, and 5 again, we will have all the height, all the width of the rectangle, yes, and this 12 is the height. Now, in this diagram that we have, this is 12, this is 6, this is 5, 5, 5, 5, and 12 again. Now, if you need to find, using the net, you have to find the area of this part, then the area of this one, and then the area of this. But let's make a big rectangle with information. Now, this is the rectangle, and then will be 12 in this part. And here we have 5, 6, and 5. That will be 16. Now we have a rectangle that is 16 and 12 in this part. Now remember, the area of the rectangle will be base times height. And we'll say 16 times 12. The result will be 192. Now this is the, sorry, I didn't focus, 6 times 12. Now this is the area of the rectangle. This rectangle, the lateral area. This is the lateral area of the prism. The 12, the 192. Now, how many triangles we have? We have 2 triangles, 1 and 2. Every triangle is 12. That means the surface area, remember, is lateral area plus 2 times the base, the area of the base. The surface area, the lateral area in this one is 192 plus 2 times 12. surface area here is 192 times plus 24. That is 216 centimeters square. This is the problem number 1. Now, I will continue with this figure number 2 in page 701, that we have a polygon as a base, and it's a prism that is here. Now we have to solve this question, that is, what is the lateral area, what is the area of the base, and what is the surface area of all the prism. But first, we have to identify what is this polygon. That, remember, we have 6 sides, and Ina Selman and Diego Amaya will let us know in the comment on YouTube what is this polygon that is here. It has 6 sides. Now, let's solve this one. Remember, we have to find the lateral area and the area of the base. The hardest part is find the area of this polygon that has 6 sides. We only have one information about this polygon, the 6. Every side is 6 because it's a regular polygon. It said that is constant, this value. Remember, we had to find the apothem in this one. With that apothem, we will multiply by the perimeter. That will be our area of this one. Okay, now let's do this. I will make this triangle here. We know this triangle, the base is 6. We are looking for this apothem that is there. Now, what is the angle that is here? It will be 360 divided by 6. Why by 6? Because are 6 sides. That is 60. And this angle is 60, but I need the half. That will be 30 degrees. If we have this triangle, we have 30 in this part, we have 3 in this, and I need the apothem. Now, what is the relation that we have here? We have the opposite and we have the adjacent. Now, will be tangent of 30 is equal to the opposite. In this situation is 3, and the apothem will be the adjacent. Apothem will be 3 divided by tangent of 30. In this situation, that will be 3 divided by tangent of 30. Remember, you may use the special triangle also to solve this answer. I will keep it in decimal. Now, here we have the answer. Is 6.196. That is the apothem. With that information is enough to find the area of this base. Remember, we have 2 bases here. Remember, the area of the polygon is, because our triangles, those are triangles with a base, with a height of 5.196, multiplied by the base. Remember, this is a triangle, the base is 6. And how many triangles we have? We have 6. Then we will multiply by 6 again. Or in other words, this is the perimeter times the apothem divided by a half. Now, this result will be 93.53. This is the area of the base, but this is one base. Remember, we have 2. We have to multiply by 2. Now, this is one of the questions. As a matter of fact, in letter B. The first one is find the lateral area. We already have the area of the base. Now let's find the lateral area here. Remember, if we make an extension, we will have a rectangles. We have the height of this rectangle, that is 12. You can see in the figure. And what is the distance that is from one side to this one? Is the perimeter of the hexagon. That means it's 6 times 6. That will be 36. Now, the area of this of the rectangle will be 36 times 12. That is, that the lateral area is 432. Now we have the lateral area. We have the area of one base. let's find the surface area. Remember, is lateral area plus 2 times the base, because we have two bases here. Now the lateral area will be 482 plus 2 times 93 plus 53. The total area will be, you have to make this in your calculator, 2 times 93.53 plus 482. That is 619.06 meters square. Now I will solve the exercise number 3 of the got it section. A cylinder has a height of 9 centimeters and a radius of 10 centimeters. What is the surface area of the cylinder in terms of pi? Now, let's do it here. With the information, we may do a diagram that will be a cylinder. I will write the cylinder vertical, but you may write it horizontal if you want. That has a height of 9 centimeters and a radius, the radius of the circle, that is 10 centimeters. Now we have to find the surface area. Remember, always is to find the area of the base. In this situation, the base is a circle. Now, the area of this circle will be pi radius to the second power. That will be pi times 10 to the second power. That is 100 pi. You may multiply 14, sorry. Now, we have the area of the base. Now, I need the area of the lateral area here. And remember, the lateral area is all around. Now, if I make a rectangle like this, I extend this the cylinder, this will be 9, and this will be the circumference, and that circumference, if we have the radius, is 2 times pi times the radius. Now that will be our lateral area. The book has this formula that is 2 pi area times the height, but it is what I explained here. Now 2 times pi times the radius, that is 10, times the height, that is 9. I will keep it in terms of pi. This one will be 90 times 2 will be 180 pi. I keep it almost in terms of pi because it says it has to be in terms of pi. Now the surface area, always lateral area plus 2 times the base. We have the lateral area 180 pi times 2, 100 pi. 180 pi times 200 pi, that is equal to 380 pi. And that is the answer of this cylinder, the surface area of that cylinder.